Hello, I'm Michael Wybrow, and in this video I'm going to give you an introduction to iOS. So, um, iOS is the operating system that runs on all of Apple's mobile devices. That is the iPhone, the iPad, and iPod Touch. And iOS was introduced when the iPhone was released, which was back in 2007 now. And it's based on OS X, or what's now known as Mac OS, which is based on Unix and Linux, and then an interface on top of that. And iOS was specifically designed for mobile devices. So what that means is it expects to have touch and gestures as the primary form of interaction, and it's designed for small screen devices. So, at this point, it's worth noting that iPads now run what's called iPad OS, which has diverged a little bit from iOS in that it has a number of additional features like mouse support or pointer support. So we're mostly not going to be covering iPad OS in this unit, though we do touch a little bit on some of the navigation components like split views that can be used to create apps that work on both iPhones and also iPads. To give you some idea of the scale of the iOS platform, these are sort of the best stats I can find. It's pretty hard to do this each year, but Apple have said currently that there are 1.8 million iOS applications available. This hasn't grown hugely in the last couple of years, and that's mostly because Apple do a fair amount of work to remove old applications that are no longer supported because there's just so many of these applications, given that the app stores existed for more than 10 years now. So the App Store has paid to developers around $60 billion from app sales last year. So that gives you a scope of the size of this market. And they say they distribute 4 billion apps each day. So a number of these will be people re-downloading them or downloading them onto multiple devices, but it's still a really large number. And also you'll realize there's a lot of free apps on the store as well as paid apps. And in terms of the size of the market, there are 1.8 billion active iOS devices worldwide currently. And this is growing. I mean, I think it was about 1.6 last year was the number. And it's worth mentioning as well that iOS apps, as well as running on these devices, can also run natively on Apple Silicon Mac OS systems. So the newer laptops and desktops that Apple released have these M1 chips, which are based on the same processors that are used in the mobile devices. I'm going to give you a quick overview of iOS architecture. And this is mostly just to say that iOS is layered. There are 4 layers: Cocoa Touch, Media, Core Services, and the Core OS. And the most important thing to understand about this is that the top of it, Cocoa Touch, is very high-level frameworks, object-oriented. As you go down in these layers, you find much lower-level frameworks, and you can do possibly more things in terms of the hardware and the device, but with more difficulty required. So the things that are at the Cocoa Touch level are very easy, and they're highly abstracted and require less technical skill. So mostly this is what we'll be interacting with. The Cocoa Touch layer provides multitasking, touch-based input, push notifications, all that sort of stuff. And some of the frameworks are things like UIKit, GameKit, MapKit, EventKit. We'll certainly be looking at UIKit, which is all of the basic user interface components, and also MapKit in the unit. The media layer provides access to multimedia, and this is things like playback, but also doing things like streaming via AirPlay and accessing graphics hardware. And there's frameworks here like AVKit, AV Foundation, Core Graphics, and Metal. Below this, we have some of the lower level frameworks like Core Data, Core Location, Core Motion, and CloudKit. And then underneath this, some of the low level stuff like Bluetooth and security and system frameworks. And some of these have low level frameworks written in C. So you can still access them and work with with iOS in this way, but there's typically a lot more work required. So when we're building iOS apps, we're doing it via Xcode. So Xcode is Apple's IDE. It's a free download for Macs. It only runs on macOS, and it's not available for Windows or Linux. So what does this mean for us? It means in the unit, if you have your own Mac, you can use Xcode on it. If you don't, we have computer labs at Monash, and as well as the sort of generous lab time that we have, there's one of the Mac labs that's available most of the time. It's not in use by any other units, and you can use it and get 24-hour access to it. And if you are not able to be on campus because you're overseas or out of state, then we will provide you with an account to an online service called Mac in Cloud, which is basically remote desktop access to use a Mac, so you can develop with Xcode. So Xcode has a code editor, a debugger, interface builder, simulators, built-in help, and all of the necessary compilers and things like that. So we'll see as part of the workshops and also in the lab exercises all of these things. And it's worth noting the latest version at this time is Xcode 13.2, and we're currently targeting iOS 15.3. Now, there's a good chance over the next few months that iOS 15.4 and 15.5 will get released, and new versions of Xcode will be released. So you can think of Xcode 13.2 as being the current version, and that's the version that we've tested all of our lab classes and things on. Quick side note, it is actually possible to develop iOS apps in the Swift Playgrounds app on an iPad, but you can't use all of UIKit. You can only use Swift UI. So this is not something we'll be covering in the unit, but this looks like it's Apple working towards eventually having something like Xcode that runs on an iPad, where you can develop iPad and iOS apps from an iPad. So that's an interesting development for us to pay attention to. So in Xcode, we have a few choices of languages. Apple's used to have a language called Objective-C, but for the last about 5 years, actually longer than that, but for the last few years at least, Swift has been the sort of language of choice for most iOS and macOS apps. And Swift was designed by Apple, but is an open source project, and it's designed to be, as it says here, a faster, safer, and more concise version of Objective-C, but with the same benefits. And the syntax for it is similar to C and C++. It's based off languages like C# and Objective-C, but there's some key differences. And it also has some unique concepts to it that you probably need to get your head around. So in the next video, I will go through some of them. Okay, thanks for watching.